Hi everyone. In this section, we are going to cover the first lesson of the year. And it's a lot of review of past material that you've had in previous years. So we're going to start with order of operations, right? And remember, order of operations basically starts with grouping symbols, parentheses, brackets, and so on. Then we do powers or exponents. Then we multiply or divide left to right in the same step. And then in the same step, we add or subtract from left to right. I'm sure you've heard of PEMDAS. So the P in PEMDAS is for parentheses, but again, it doesn't have to be parentheses. It could be brackets and so on. So that's why we do grouping symbols. Then it's exponents or powers. Then again, M and D multiply and divide in the same step, add and subtract in the same step. Okay, so here. So we're going to evaluate the following expressions. If M is 12, Q is negative a half. And I know here there are supposed to be parentheses. Okay, so this is equal to M is 12 minus, in parentheses, 3 minus negative a half squared. Okay, so 3 minus a negative, that will be a positive. So here, I'm going to do the stuff inside the parentheses first. So 12 minus, in parentheses, 3 plus a half is 3.5, which is 7/2. And then I need to square this. When you square something, that exponent belongs to the 7 and to the 2. So this is equal to 12 minus 7 squared is 49 over 2 squared is 4. So again, a quick review of adding fractions. This has a denominator of 4. So if this has a denominator of 1, I need to multiply by 4 on the top and the bottom. So this will be 48 over 4 minus 49 over 4, negative 1 over 4. Okay. One thing I want to draw your attention to is the following. So notice as I'm going down here, I have my equal signs. But more importantly, look at how I have equal signs when I go, when I write steps from left to right, I have equal signs in between my steps, right? We can't have it any other way. So I can't not put that there and then, just go, okay, I'm going to go next to it and write the next step and then next to it and write the next step. No, it doesn't work that way. You can't just list step after another next to each other without putting an equal sign there. Okay, so we need those equal signs there. Okay, so let's move on. Here I have M, which is 12, plus 2 times negative a half, plus 4. So that's 12. This will be negative 1 plus 4, and that is 15. Okay, next one here. So I have a fraction here. All right, so let's continue. So if I want to keep that fraction, I need to keep that fraction bar intact. So J is a negative number. And if I want to raise a negative number to an exponent, I need to put it in parentheses. So negative 1 squared minus 3 times H, 4 squared, times K is 0.5, over J, which is negative 1 cubed in parentheses, plus 2. So negative 1 squared is going to be positive 1 minus 3 times 16 times 0.5 over negative 1 cubed is negative 1 plus 2. So this is 1 minus 3 times 16 times 0.5 is 8 over 1. So that's 1 minus 24, negative 23 over 1, which is just negative 23. Now, before we move past, okay, I actually want to do a second version of this. And I'm going to keep all the values the same, right? Except I want to change the k from 0.5 to, I don't know, 0.3. Okay, so now let's see what we have here. So we have the same situation, negative 1 squared minus 3 times 4 squared times 0.3 over negative 1 cubed plus 2. Okay, so take a look at what we have here. Negative 1 squared is still a 1 minus 3 times 16. And then I have a 0.3. So now if I multiply this, right, 3 times 16 times 0.3, that's honestly too much unnecessary multiplication. Remember, you are not going to have a calculator available to you for any of this stuff. So the 0.3, instead of leaving it as 0.3, it is much wiser and actually necessary to write it as 3/10 over negative 1 plus 2. Now take a look at what happens. I have 1 minus, here I can actually reduce these by 2. I get an 8, I get a 5, right? So now it becomes a little bit of an easier problem because now I have 3 times 3 is 9 times 8, 72 over 5 over 1, okay? So now 1, this one, I want to make it into, a denominator of 5. So that's 5 over 5 minus 72 over 5 all over 1. And I can do that much more easily. So remember, on your homework as well, whenever you have, these, make sure you change them into fractions. All right. So here we have a formula that represents the conversion of temperature from Celsius to Fahrenheit. We want to see what is the Fahrenheit equivalent of 40 degrees Celsius. Okay, so this 40 degrees Celsius, that's basically your C. So C is 40, and I want to know what F is. All right, so my formula says F is 9 over 5 times C plus 32. 9 over 5 times 40 plus 32. This and this reduce, I get an 8. So here F is 72 plus 32, which is 104 degrees. So that'll be 104 degrees Fahrenheit, right? So if you have a fever of 40 degrees Celsius, that's the same as having a 104-degree fever, right? Or if you go to Europe and they're like, oh my gosh, it's going to be 40 degrees tomorrow, and they're complaining that it's hot, right? And you're sitting there going, 40 degrees, that's so cold. Well, Celsius versus Fahrenheit. Okay, so that was section 1. Let's go on to section 2. In section 2, we're going to talk about properties of real numbers. So basically, right up to, the end of chapter 4 or so, all of the numbers that we are going to deal with and all of the numbers that you have dealt with from the beginning of your lives were real numbers. Now, those real numbers can be classified into 2 big regions. One group are the rational numbers. So think about what it means when somebody tells you, oh, so-and-so is a rational person, right? What do you think about that person? Is it maybe that, there's somebody that just kind of makes sense? I think so, right? Rational numbers are similar. They're numbers that you can basically make sense out of. The definition of rational numbers is that they can be expressed as a ratio, A over B. So for example, 7 over 3 is a rational number. Negative 2 over 5 is a rational number. 9 is a rational number because I could actually, say it's over 1, right? So that could be expressed as a fraction. 0.5 is a rational number because it could be written as a fraction, 1/2, right? Now, notice just in these 4 examples that I gave you, we already came across different classifications, right? So for example, we have ones that have a denominator that is something other than 1. And then we have others that have a denominator that is a 1. Well, the numbers where their denominator is a 1 are called integers. So integers are positive, negative, or 0 that can that have a denominator of 1. So for example, -3, -2, -1, 0, 1, 2, 3. And these extend on both ends. So basically all of these are numbers which have a denominator of 1. Now, so from that large list of numbers, if we strip away this half, what are we left with? 0, 1, 2, 3, ... Those are the whole numbers. So they're basically integers, but all the negative numbers thrown away. So 0 and up. Now, if I was there with you, I would point to somebody randomly and I would say, hey, can you please start counting? So why don't all of you in your head start counting? Go. Okay, so you probably all started at 1, 2, 3, 4, right? Yes, because when I say to count, we don't usually start from 0. Okay, so like nobody says 0, 1, 2, 3. We don't do that. And then nobody starts counting at like 7, right? We start counting at 1, 2, 3, and so on. We naturally start counting at those numbers. So those are the natural numbers. Okay, so let's see where we're at so far. We had the real numbers, and then we classified those into 2 regions. One was the rationals, and then, you can have, in the rationals, you can have an integer, a whole number, what else? A natural number. Okay, the next branch of this, if it's a real number, it's either rational or, irrational. Okay, so what's an irrational number? Well, what would an irrational person be like? Well, it would be somebody that you kind of can't make sense out of, right? There's like no rhyme or reason to them. That's what irrational numbers are. Irrational numbers cannot be expressed as a ratio. They're basically decimals that repeat without a pattern. Okay, what's the one number that just goes on and on and on and on and on forever? Pi. Okay, 3.14151926, blah, 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 right? No rhyme or reason. Another one would be root 3, 1.713, blah, 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 blah. Root 15 is another one, right? These are all irrational numbers. Okay. All right, so moving on, here are more examples. One thing I want to draw your attention to, take a look at this one, 2/3. This is 0.66666666. Okay, yeah, it doesn't end, but is there a pattern? There is a pattern. You can make sense of that pattern. So that is a rational number, right? Okay, all right, so let's see all the sets to which these numbers belong. So they're all going to be real. So I have to start with that. -185 is a real number. Next, let's go up here for a minute. You have to ask yourself the first question, which is it rational or irrational? Well, -185 is rational. And then you have to see which one of these 3 it fits into. Is it an integer? It is an integer. And it's negative, so it's not a whole number or a rational number. Okay? Now, the book, I guess they just kind of get lazy at writing all these names. So they have these abbreviations. Honestly, okay, I get it. W is whole, N is natural, I is irrational. But then there are, like, I can remember Q is rational, Z is integer. So I'm not going to have you memorize those letters. It's unnecessary. You could just write out the words, and that's totally fine. Okay, root 49. Well, root 49 is a sneaky way of writing 7. Okay, so it's real. And then let's ask ourselves, is it rational or irrational? Okay, it's rational. Now, is it an integer? Meaning, is the denominator 1? Yes, it's an integer. Does it fall into the whole numbers? It does. Does it fall into the natural numbers? It does. So it's all of them. Okay. Root 95, it's a real number. Okay, can we simplify root 95 like we did the 49? No. So let's ask ourselves, is it rational or irrational? Okay, this one's irrational. And once you determine that it's irrational, you can't go further than that. That's it, we're done. Okay, -7/8, it's real. Is it rational or irrational? It's rational. Okay, is the denominator 1? No, it's not. So we can't go any further, right? It can't be an integer or a whole number or a natural number. Okay, so that's it. That is the homework. That is the notes for today. As far as homework is concerned, all right, so if you go here, under topics, is your lesson plan for B period. And so you see here, this is what we did today, 1.1, 1.2, 9.4. This homework 1 is your homework that is going to be due tomorrow, Thursday. All right, so to do your homework, you're going to go back to the MyJag page. In the bulletin board, on the right-hand side at the bottom here, or the bottom link here is your textbook. You click on that, and you are going to log into your textbook just like we did last time. So you're going to go first to page 7, and you're going to do that. Now, a little bit of formatting. On each of your homework, I need a couple of pieces of information. I didn't go over this the first day because it was just too many things. So if this is your paper, all right, I need 4 pieces of information. I need your name. Now you can write it either here or on the right hand side. I really don't care. But you put the homework number, right? So in this case, this is homework number 1. And it's section, the first one is section 1.1. I really don't care about the page number. So you're going to put homework number 1, and you're going to put that this is 1.1, and you're going to put the number of the problems. I'm just going to guess at random here. All right, you're going to put all of them. Most of the time, you're only going to have homework on one section. It's only now that it's the beginning that we're doubling up. So after you do this, either go on the back page or, put clearly a line here and then do 1.2 and then put the numbers over there and you can do your homework, right? Okay, and I think that's it. So basically, let's say like you'll put number 19 and let's say it's like, a squared minus bc. Write that and then put in the numbers. Okay, I'm just literally making up stuff off the top of my head. Okay, and then that's how you would solve. All right, everybody, thank you so much.